All right, so first, let's have a look at your web application stack as it is today. This is kind of like my let me guess game. Probably Django, right? I mean, some of you probably use Pyramid or Flask for some things, but since we're at the Django meetup, I surmise that most of you have built around Django. Now, Django REST framework has taken the community, I think, in the years I've been using Django, I don't remember ever seeing a project go from total obscurity to such overwhelming success as Django REST framework. So, Tom Christie can be very proud of that. But my talk doesn't assume you're using Django REST framework. I just use this to demonstrate. So Django REST framework sort of lives above Django, and then beneath you have like this network traffic, right? You have that pesky internet with your pesky users who keep pinging your application over and over again and wanting things of you. And between the two lives this sort of black box, right? And I think of this black box, the networking part, the part that reminds you that fundamentally your app is an application of network engineering. We kind of treat this like an election for highway superintendent, right? You get in the booth and you have to choose one, and you don't even really know like what this position does, and even if you did, like how would you choose one over the other? But you have to make a choice. So for a long time, it was Graham's product ModWhiskey, which plugged into Apache, was like the thing to use. And then of course, G-Unicorn. WSGI, right? So WSGI, the Web Scripting Gateway Interface. That's what they call this. That's what this black box has been named by our community. Quite possibly, I think, the stupidest acronym in the history of network traffic. What do we learn from this acronym? Web Scripting Gateway Interface. We wasted 4 letters and learned nothing about what this piece of machinery does, as far as I can tell, right? So I think G-Unicorn is clearly kind of the cool kid in town right now. A lot of people use MicroWSGI as well. And obviously, these two account for, I think, the majority of Django projects right now. But what I'm here to tell you about is another player in the space, as it were, called Hendrix. So Hendrix came about when I really wanted to, I had an X10 module hooked up to a computer that was hooked up to the heat lamp on my pet Python, for my pet Python, and they need to be turned on and off, sometimes remotely, sometimes on schedule. But the X10 command takes like 8 seconds, right? So the browsers are like spinning for 8 seconds when I refresh the please turn the light on or off lamp. So got me thinking like, why does it have to be this way? This is like 3 or 4 years ago now, before a lot of the sort of parallel advancements had been made with gEvent and Celery and such. And so that led me to this thing, Twisted. Now maybe you've heard of Twisted. I imagine you probably have. Twisted is a network engine. It's fairly old, fairly mature in terms of a Python project. It's been around a while. It's really super battle tested. Twisted has done, has powered a lot of the most serious Python applications for many years. And I think, we need to I think it's time to, as a community, let's talk about Twisted. How did we get to a point where for the most part, our view of our web application is that it is this higher level construct separated from the networking engine, and we don't even use the most powerful network engine that Python has to offer. I even think, for my money, I think Twisted is possibly the greatest open source project in terms of its commitment to quality. The Twisted code base is really, really clean, really well maintained, and very, very actively maintained. And instead of using it, we now have this situation where I feel like we're all kind of wandering a little bit confused about how we deal with our network layer, so much so that we're saying, oh, Python doesn't really do sockets that well. JavaScript does. That's bizarre. It's a really weird state, and it's not the state of the technicals, I think, that has driven us to this position. Instead, it seems to me that it's sort of like the state of the community, the state of communication between our various projects. So if you want to build a game with Canvas and you want it to be multiplayer, I think Python has wonderful tools for doing that. So let's actually get to some Python now, right? So I am going to, at this point, so let's take as read that I've already pip installed Hendrix and pip installed Django. Okay, that's in media res, right? Here we are. Hendrix demo, right? Now again, I've already pip installed Django, already pip installed Hendrix. So I'm going to go into my Hendrix demo, and Hendrix provides a facility, HX, which is sort of like the G-unicorn binary. I run hx start ---- dev, and this gives me something that looks and feels basically pretty much like Django manage.py run server. Okay, so let me, well, just to verify here, we go to localhost 8000. Indeed, I have typical Django project. Okay. Now, to me, I actually, this is another thing that I don't care for about G-Unicorn and MicroWhiskey, and that's not to bash or dig the maintainers, because I think G-Unicorn and MicroWhiskey are actually wonderful projects. But this, to me, this methodology of running this binary that ships with something that you pip installed, now I wouldn't even know where to put a breakpoint. You know, and I've never been super comfortable with that. Like, to me, the right way to do something in Python, generally, all things being equal, is to import that thing and call it. So let's open up the project we just made. So it's going to be a typical Django project, of course, because I just ran star project. So this is going to be a fresh Django project, just out of the box, the way that you're used to seeing it. Okay, I've got manage.py, Hendrix demo, as you might expect. Next to manage.py, I'm going to make a file called run.py. This is the file I want to use to run my project, because I'm going to treat it like a Python project, right? And in run.py, I'm going to kind of replicate the exact functionality that you get with that hx that I just showed you. Okay, so I'm going to import from hendrix.deploy.base. I import hendrix deploy. Okay, and then this is going to give me a deployer object. Hendrix deploy. I need to pass it. I can pass it either my settings module, which for political reasons I find distasteful, or the WSGI application object. So I'm going to choose the WSGI application object, which is at hendrixdemo.wsgi.application, again, because this is just a fresh Django project. And then I'll do deployer.run. Okay, and those 3 lines, I believe, will be sufficient to run the project. Listing on port 8000. I'm going to come over here, refresh the page. So again, what did I do? I pip installed Hendrix in Django. I ran Django admin star project to get a totally naked Django app. I first ran hx start, and hx start works, you know, more or less like the Django run server. Okay, and then I did the same thing here in my run.py. Okay, Hendrix deploy. All I have to do is pass it the WSGI application and run deployer.run. This works for any, not just Django, of course, but any WSGI framework this will work for. If your WSGI application does something tricky, you know, if your WSGI.py, if you've added logic there that uses really anything in Django, imports anything from Django other than get WSGI application, then you might have to do settings.configure first. Probably if you're someone who front loads things in WSGI.py, you're probably used to having to run settings.configure, but that's just kind of a little gotcha with Django. Of course, Django can't do anything without its settings having configured. You know, it's called the lazy settings object, but it's like the most motivated object I've ever come across in any code base. It just wants to, you know, no matter what you try to do, settings has got to be a part of it. So here I'm able to run, you know, basic Django project, right? So now let's go through what, you know, the logical next step here is of course to make an app. Start app, we'll call it Noodles. Okay, so this of course makes my app. And now inside the app, let's just make a really, you know, quick view and a template just so we can kind of know that we're, you know, my Noodles for request, and that will render a template called noodles.html. Of course, I've got to include the request object, and we'll have no context, at least for the moment. Okay, we're going to add a template here. templates directory. I know you've all seen this before, but I just wanted to really make sure that it's obvious that we have a very clean, brand new Django installation here. So noodles.html, we'll just say noodles in here. Okay, then of course we've got to go up over to settings and make sure noodles is installed. Okay, we've got our view already, so we'll just pipe a URL to that. Our URL will be my noodles, I suppose, and of course that will be the noodles app.views.mynoodles. Okay, so I'll restart the server. I'm not a big fan of the reload every time that Django run server does, but I think it's just because I run a debugger every time. But with Hendrix provides the same -- reload observer service. But I don't know. I don't like to rely on that. I like to have to restart the server every time myself. Good. My noodles. We have noodles. Okay, good. Now, here's a bridge we've all had to cross. Suddenly, in my noodles, I'm making a bunch of calls to the Bitly API. I'm using requests. I'm doing file I/O. I'm doing not something CPU bound. I'm doing network I/O or file I/O. I'm making a call to an API service, or maybe a bunch of calls. Okay, we'll represent that here with a loop. I'll say for I in, say, a range of 5 calls that I'm going to make, and we'll say that each of them is going to take a second. Okay, some API calls do take a second. I know that seems long, but it happens, right? That's not unheard of. And now, of course, if I run this, okay, this is a really, of course, silly way to do things because my browser is now going to spin for 1 second for each of those iterations, right? Here we go, 1 Mississippi, 2 Mississippi, you all played flag football. And so now eventually I load here. Great, okay, so the way that we handle this in Hendrix, I'm going to put this in a function. I'll call it myLongThing, okay? And now I will import. This is one of my favorite import statements that I've ever been responsible for. From hendrix.experience, I'm going to import crosstown traffic. And I'm going to decorate this function, crosstown traffic. And now, when the view gets to this part of the function, it will do the following. It will return the response first. Then it will examine the status code of the response, and if the status code is not in the 400 or 500 series, then it will spawn a new thread and run this on that new thread. So now you can see, in fact, just to show that it's doing that, we'll print another noodle in here. Okay, so we'll at least have evidence on the console about what's happening. Okay. That loaded quickly, obviously, and now we have another noodle there happening on another thread. Now, I know you hear like threads are like super hot lava. Like, you know, I see people come into the Django IRC channel, or I have clients calling me, and they're like, you know, we're like deep in like learning Celery, and we're going to understand G-event and all these, you know, like I'm training all my guys on concurrency patterns, and you know, I'm like, listen, man, it sounds, you know, you have like a couple API calls, and this is resulting in a complete restructuring of your development team. You're like learning, you know, you're like having to totally change the nature of your company. Threads are awesome if you're network I/O bound. They're really performant. You save the 25 to 35 milliseconds that it takes to spin up a process, and there's really no loss. If you're CPU bound, that will block the entire worker, right? So don't calculate 10,000 Fibonacci numbers in there. But if you have 200 API calls to make, this is no problem. If you want to talk to the ORM, it's no problem. This is a really, to me, this is the easiest, simplest pattern for doing async in Django that I've seen. And I assert that this is the one obvious way to do basic threaded asynchrony inside a Django view. Now, you go ahead and look at the crosstown traffic documentation. If you do this, you'll see that there's a few other options, like you can set no-go status codes. Okay, I mentioned before that that will be 400 or 500. Normally will cause this not to execute, but if you have other status codes, if you want to set your own status codes, you can provide a list there of which status codes will or won't happen. If you want this to run on the same thread, if you want it to hang the worker thread until this is done, in other words, it will return the response, do all your stuff, and only then go back to listening for subsequent users, you can set same thread equals true, and there are a bunch of those kind of options to kind of tailor this decorator to run this little closure the way that you want it. Right?
So this, that thread that you've launched, though, it's not able to provide any data to the response. So.
It's not able to provide any data to the response. That's true, but you've anticipated my next demonstration, which is that we are going to now, inside here, so I am perhaps brave or stupid, depending on your perspective, enough to do Python live demo, but I'm not going to do any kind of JavaScript live demo. So I've got something I'm going to copy and paste here. So Noodles is now going to turn into this this template. Okay, and all I'm doing here, I'm including, I like sock.js, maybe you like socket.io, whichever, of course, just to consume WebSockets. I'm including sock.js here on line 1. I'm subscribing to hendrix demo/messages. I'm saying on open, I want to subscribe to Noodly messages, and then on every message, I'm going to log to a function, and I'm going to modify this div down here to add a new function. Okay. Now I've got to do some networky stuff to be ready to send these messages over the wire. So in my run.py now, I'm going to add just a few things. I'm going to add a few import statements. Okay, again, I'm using txsock.js on the back end, but if you want to use, you could use socket.io on the front end even if you want to. But I import this sock.js resource, a message handler protocol from Hendrix, a named resource from Hendrix, and a little factory. You'll see how those all work. Okay, I need in twisted language, a resource is sort of like a page was on the original web. So this is saying before you get to the URLs dispatcher, check to see if there's a resource at that URL. And then down here, so now I have my deployer. Within my deployer, I'm going to then append that resource here. I don't need that one twice, obviously. So, okay. So right, I have a message resource, and this is what's going to allow my subscribers from the front end to subscribe. And all I have to do is append that to the deployer, and it will listen without any further configuration. And then, as you can see in the template, what do we call it? My noodles or whatever, right? Oh, right in the middle. Oh, noodle. I was looking for my noodles. Yeah. Okay. So in the template, we'll have this action. It will get appended down there, and then in the view, I have a little utility here. So instead of printing, we're going to do hx dispatcher. This, by the way, in Hendrix 3 will be a different API. It will be from hendrix.experience import Hey Joe, and then you'll be able to Hey Joe to send messages out. Hendrix dispatcher.send. And again, the little pub sub name there was Noodly messages, I believe. I'll confirm that. And then I'm going to send, again, the same message here. Instead of printing, we'll do another noodle. Okay, so it's true. I can't, in the way that a Django stream response can affect the response, I can't affect the response here. But what I might be setting up here, like in the case of the game, is I might have my Angular or my React application, and I want that to load as quickly as possible, and all the data that I have, whatever APIs I want to reach out to, whatever ORM calls I need to make, that can all happen in here so that the user gets that response right away, is able to start rendering the front-end application, and then it can be populated with data when the data is ready. Okay, so you can see it connected to the WebSocket. Okay, got the 101 status code, switching protocols. Didn't load there, I suspect because we've got a pub-sub mismatch. So let me just check that out. Views, got noodly message here, and in the HTML where I'm subscribed, got noodly messages. So that's my bad. So again, good opportunity to note, this is your pub-sub ID right there. That can be unique, doesn't have to be unique. If it's obviously not unique, then you have a broadcast. Noodly messages. There we go. Another noodle, another noodle, another noodle, so on, right? So to me, that's a pretty simple way to have sockets up and running. Again, if you're doing CPU-bound stuff inside that crosstown traffic, you want to move that somewhere else, like another process, right? But that's not too hard. In your other process, you just repeat, what we've already seen here. Now I want to do one other thing that's quite a bit weirder, a little bit groovy. Do I have time? Okay, so now let's imagine, again, we live in port 443, port 80. We're publishing things on the web. People are accessing them in their browsers. But I think it's important to remember that we stand on a long tradition of network protocols. So imagine that I want this application not merely to listen on port 80 and 443, which we've been trained to call a web application. I want it to listen on telnet, and I want someone to be able to telnet in, and any data that they send over the telnet socket, I then want to display that here. Now, that, I think for most people that sounds like insurmountable, right? Because now I've got to go look for another application. I don't even really know how telnet works, and then how am I going to have it listen on the port at the same time, and then I'm going to have some kind of communication protocol to bring the two processes together. But again, Hendrix and Twisted regards your web application as just another network resource. It's just a thing that listens on port whatever, in this case 8000, right? So if I want to do something like add, and I picked telnet mostly for comedic value. If I want to add something like a telnet listener here, I really don't have to do all that much. So I'm going to come back to my run logic. And again, I see nothing wrong with having some density here. I'm not a big fan of just going to the command line, typing hx, and thinking that it's starting. I kind of like the run logic I can imagine dividing this up into multiple modules and kind of doing a lot of stuff before you start. Maybe you're doing some authentication. Maybe you're spawning other processes. Maybe you're checking out the database. Maybe you're even doing migrations in here. Personally, I see nothing wrong with that. Here I'm going to add a couple more import statements. I know this is not exactly PEP 8, but I just kind of want to keep it a little bit separate for educational purposes here. I'm going to add, so now I'm going to need to import telnet transport, telnet protocol, and from twisted.internet protocol, a server factory. So this is where you get to kind of the twisted language, which I think which for years I think was some kind of a turnoff for people, because the twisted lingo is a little bit different. It's a little trippy and a little crazy, but I think that now, as far as I can tell, the internet has kind of caught up to a lot of these ideas, and I think today this feels really good. So I'm now going to make a class for my telnet to WebSocket. Okay, this is going to be my telnet to WebSocket server. And here I'm going to subclass the telnet protocol. In the world of Twisted, a telnet protocol doesn't necessarily need to live on a telnet server. These are sort of disparate concepts. You could have a telnet protocol on an email server or something like that, or at least that's kind of how Twisted is designed to be. This thing has a boatload of methods. Right now I'm just going to override one called data received, and this is simply what to do when some data is received. I'm going to use that same HX dispatcher that we had before. Again, the thing that in 3.0 is going to be called Hey Joe and be a little more elegant. But works great now, and this API is here to stay as well, or here at least for a few versions. And now I'm just going to send that data over the WebSocket. Okay, and that's it. That's the entire telnet server. I just wrote an entire telnet server. The only other thing I need to do is to make sure that my telnet server listens when at deploy time. This deployer dot here is going to listen not only to port 80 and port 443, but another port that we're going to choose. And to do that, I need to create a telnet server factory. Okay, I imported my server factory. Imported my server factory, and then I'm going to set the protocol for that factory to, and this is going to be the weirdest part of the whole demo, and this is something I don't really love, but it's the way it has to be because it has to be a callable. This is going to be a lambda, and I'm going to use that telnet transport to consume my telnet WebSocket. And this will all be on GitHub if you want to take a look at it. I know that's kind of weird. I don't love that, but you know, they're kind of fastidious. Like they want that always to have to be a callable. And then down here, I'm gonna in my deployer, I'm gonna grab the reactor from the deployer. Let's take a quick minute to talk about that. The reactor is just the event loop in Twisted. And this is a good time for an aside. People say, I think a lot, there's this notion that, well, with Python 3 we have async.io, and so Twisted is going to kind of go away in some sense. But really, I think the only thing that async.io even might replace is this reactor. The Twisted folks, for many years now, have maintained their own asynchronous flow control, and I think they deserve a lot of credit for that. And now, hopefully, that Python has native primitive async flow control. This part of Twisted can be deprecated, but all this other stuff I think will run wonderfully over the top of async.io. In fact, I think, as far as I can tell, Twisted is at the beginning of a really awesome run right now. So I'm going to do deployer.reactor.listen.tcp, and I'm going to pick a port, let's say 6565, and here I pass my telnet server factory. I'm not having complete luck today. There we go. So I'm going to run this, absent any syntax errors that anyone might see. This is noodling messages, that's the same. Say again. So I'm listening here, we're going to do the same. We'll see our noodles here, and if all worked well, I believe I will be able to now telnet localhost. You didn't think you were going to see telnet tonight, did you? That's 6565. And I'll say hello world. There it is, right? Just like that. And I can do that with an SSH server, with an email server, with an IRC server, or an IRC client. I could have this telnet. I could right here. I could have this hello world could get passed into the Django ORM, Django.objects.filter. You know, name equals hello world, and I could return objects on the Django ORM. If I'm building a game, I can do all this sort of over-the-top traffic here to manage my multiplayer between sync my canvases up between multiplayers. But then underneath, I can easily have these network services that talk, to other parts of the world. I think this is a super elegant way. I don't understand why we don't yet do this in general as web developers. I think that we have so much fear of that black box in my first diagram that we've decided that it's easier to be disempowered than to learn a relatively small and super groovy set of tools that allow us to really expand beyond that box. So I hope that you will give Hendrix a look the next time you're about to start up a Django project. I think it's really battle tested. I think it will scale really well. The largest company that's using it right now, and a company that has dedicated quite a bit of development time, tens of thousands of dollars of development time, is Relio. Relio is just a few blocks away here in New York City, and Relio is completely run on Hendrix, and it seems to be working very well so far. The GitHub for Hendrix is right here, and I do want to just draw your attention briefly to the core contributors, my buddy Anthony, myself, Damon, James, who's in the room back there, and Kieran Prash. The five of us are, the commit bidders, and we're really super excited about this. I think that in many important ways, this represents what I think the web or the internet or what internet activism can be. And if you think so too, then pip install it and give it a try. Questions? Either way, yeah, sure. Peter, if you wanted to.
Does everything runs on the same port?
No, nope. I had, in this case, I was running on 2 ports.
No, wait, without the telnet. Just hendrix and the WebSockets.
Yeah. Mm-hmm. Yep. So, yep, telnet runs on a different port. The The hendrix instance runs there on port 8000. Yeah. Yeah.
Are there some examples in that repo?
There's one that's a chat and one that's a little game. Yeah. And I will publish this as, I guess, under my own GitHub under Hendrix demo. Yeah.
So one thing that scares me about like async threads spawned from request and response cycles is you don't really know what those threads are doing. Are there like monitoring solutions built on top of this? I know it's not like a key system, but like something like Flower is like really nice for Celery and you can know what the call is going on. If like a thread dies or hangs, you get like stack trace or whatever. Are there solutions built on top of it?
Yeah, there are. So Twisted has its own thread library that has solutions for things like inter-iteration, error handling, success handling. And so, of course, you're free to use any of those things. I mean, my advice generally is if you have that kind of apprehension about what's happening on a thread, which is totally reasonable, then probably don't use crosstown traffic. There are other APIs that you can use. We actually have another project that we're kind of like what Hendrix does maybe to G-Event, G-Unicorn, MicroWhiskey. We have another project called Tiempo where we've got Celery in our sites. And Tiempo also uses Twisted and has sort of much more robust thread management, and it has a WebSocket driven front end that shows you what every thread is doing, and so you can take a hint from the Tiempo. It is, yeah. This is Hangar Underground is Relio's sort of code name, Hangar Underground /Tiempo. So you might want to take a look there. But yeah, I mean, I think there's no shame in, by the way, there's no shame in using Celery or using your message queue of choice. My point is that most people, most of the time that I talk to, they're like, I just want to send out a few emails. I just want to do an API thing, and I don't, I want to keep my 80 millisecond or 150 millisecond response time, and I'm bubbling up to 600 milliseconds. I'm not even doing anything that mission critical. Like if the thread it wouldn't even be the end of the world. I just want to keep my response time reasonable for this one little thing. So that's kind of the angle with crosstown traffic. But there are other APIs to do more elegant or more robust concurrency. The weird thing there is you can't do it with a closure. That's what I like there. There's no real way to do. So if you've really looked under the hood at Celery, there'd be no way to do this because Celery has to pickle your task, and you can't pickle that. So. It's a callable, right? And it's really a closure, right? So the context out here, like if I have llama equals true right here, I can access llama in here. That's kind of the cool thing about it is I can make a quick ORM call in here, and then I can have some logic in here that decides if I want to make way more ORM calls or API calls in here, right? And that's the kind of thing that's kind of tough to do with Celery. Other questions? Yeah.
This just kind of relates to something very basic I'm doing right now, which is server-side analytics. So right now I'm using Python analytics from segment.com, which just magically does it, I believe, on a thread. And I'm about to switch to Celery for that. So this is a very basic thing, right? We're just making a call to an analytics provider like Google Analytics.
Okay.
For each server call. So this seems to be directly with what you're talking about. So I just wondering if you have any thoughts on that.
I mean, I'm gonna have to. I don't know. I give it a try, maybe. See what you think. I don't know. I mean, if it's truly just network I/O bound, I like doing network I/O bound things on threads.
And I guess the other thing is, how practical would it be to port a Django project that has to run under Apache from WSGI to this?
So I've heard this before, and it's never quite. I'm sure there are awesome reasons that are just not on my radar yet. But why do Django projects ever have to run on Apache?
I have all kinds of things. I have a web dev server. I've got tons of rules for all kinds of other related stuff. I have a lot to my project.
Can't you just doesn't Apache have the equivalent of an Nginx proxy? Like, can't you just do proxy pass?
Yeah, I can proxy.
So maybe proxy passes away. I mean, Apache's not going to add any overhead, I don't think, right, or very little. So maybe you want to do proxy pass. And by the way, will never speak ill upon ModWhiskey. Graham Dumpleton, who wrote ModWhiskey, is just a really awesome dude and really knows what he's doing. And ModWhiskey, if ModWhiskey is working for you, then rock ModWhiskey for sure. But if you want to do, if you want to use these APIs, then yeah, you're gonna have to either proxy pass or something even more severe. Other questions? Cool. Well, it's been awesome meeting you all. I'm in the city several times a year, usually for work. I have a few clients here. I might possibly have some availability like next spring and summer. So if anyone needs, consultation development on kind of advanced asynchrony concurrency, feel free to drop me an email at justin@justinholmes.com or look me up at GitHub or whatever you like. And thanks again. This has been awesome.
So let's get those lightning talks going. I saw some hands in the back.